and welcome back to the second part of section 1.2, and this is where we're going to talk about sampling. Oftentimes, to be able to survey an entire population is impossible. It's just too large or cumbersome. So what we do instead is we choose a sample of the population to represent the entire population. There are various methods for doing this, and we're going to go over a few now. The first method is a simple random sample. So you give each member of the population a number, and you randomly generate a list of numbers to select people from your sample. So let's look at an example of how this would work. Let's say I want to select 4 students in my class to receive extra credit, okay? So what I can do is I can put one way I could do that is I could put all 30 names of students in a hat, shake the hat, and pull out 4 names. If I wanted to do this using a little more technology, I could assign a 2-digit number to each member of the class and use an online random number generator. That would look something like this. These are made up names, okay? Here are the 30 members of the class. And here's a screenshot using an online random number generator. I said to generate 8 random numbers between 0 and 30. Just Google random number generator. It's super easy to use. And I would just use the first 4 random numbers. So 29 would be Way, 5 would be Cunningham, 4 would be Quaresimo, and 2 would be Batista. 2 would be Bayani. Oh, it looks like there's 31 people in this class. Whoops. All right, so what we're going to do next is, I didn't count the 0 person. That's okay. Excuse me. I did say to generate numbers between 0 and 30. I guess there's just 31 students. Anyway, here's my random number. Let's cut this part out. Okay. So I generated 8 random numbers between 0 and 30. The first number is 29, so that would correspond to student Way. The second number is 5. That would correspond to Cunningham. 4 would correspond to Quaresimo, and 2 would correspond to Bayani. So there would be my 4 students that would receive extra credit. You can generate as many random numbers as you want to using these simple online random number generators. Another method of sampling, a different method, is to do a stratified sample. Sometimes the data suggests that you want to sample people from different categories called strata, okay? So maybe here's my entire population, and maybe I want to do it by age. So maybe the light green represents 0 to 25, the blue 25 to 50, the purple 50 to 75, and the dark gray 75 to 100. So first I divide each person into their strata, and then I do a random selection among the strata. So I select 4 from the youngest age group, 4 from the 25 to 50, 4 from 50 to 75, and 4 from 75 to 100. To get my sample, I get exactly 4 members from each strata. So that's stratified sampling. You first divide into groups and then you perform a random sample. A similar but slightly different method is cluster sampling. So in cluster, you first divide the population into groups, and then you randomly select the groups, but everybody in the group gets sampled. So maybe the one to me that always strikes me for this one is you're maybe sampling customers at a restaurant, and these are your tables, all right? This picture shows that every table has 6 people, but that doesn't necessarily have to be true in cluster sampling. You could have a cluster be 2 and a different cluster be 7. They don't have to be the same size. So here's my restaurant. Everybody's at a table. I randomly select these 4 tables, and then I perform my survey or whatever I'm doing statistic on that sample. So that's cluster sampling. Systematic sampling. This one I think of when you're standing in a line. Let's say you're waiting in line for a PlayStation 5 or 4, whatever the heck just came out. And you're going to select every second out of every 4th people. So you count 1, 2, 3, 4 people, and you take number 2. 1, 2, 3, 4 people, you take number 2. 1, 2, 3, 4 people, you ask number 2. It doesn't have to be second out of 4th. It could be third out of 10,000 if you're in a big long line. But that's a way of doing systematic sampling. Now, remember, they don't physically have to be standing in line. It's just sort of the way I like to picture it in my head. The next method of sampling is convenience sampling. This one sometimes uses results that aren't as great. So convenience sampling is just asking the people who are near you. So maybe you're standing, you want to do a survey of your English class, and you want to know what everybody's getting on their last test. You just ask the people sitting at the tables near you, hey, what'd you get on the test? What'd you get on the test? That'd be convenience sampling if you decided what the test average was based on those people sitting near you. All right, let's practice recognizing these different types of sampling techniques. So A study is done to determine the average tuition that San Jose State undergraduate students pay per semester. Each student in the following sample is asked how much tuition he or she paid for the fall semester. What is the type of sampling in each case? So, what I would like you guys to do right now is pause the video, read these examples, and decide what type of sampling you think was used for each one. Pause the video now, and then we'll come back and unpause, and I'll go over it with you. All right, are you back? Let's look at A. It says a sample of 100 undergraduate students is taken by organizing the student's name by classification, freshman, sophomore, junior, senior, and then selecting 25 students from each. Well, they were put into strata by their year in school, so that is stratified sampling. B, a random number generator is used to select a student from an alphabetical listing of all undergraduate students in the fall semester. Starting with that student, every 50th student is chosen until 75 students are included in the sample. Starting with that student, every 50th student is chosen until 75 students are included in the sample. So that's going to be every 50th student down the list. So that's going to be systematic sampling. A completely random sample is used to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. That's a simple random sample. D, the freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4 respectively. A random number generator is used to pick 2 students of those years. All students in those 2 years are in the sample. Well, this is actually a cluster sampling because we clustered them into their groups 1, 2, 3, and 4. And we're not getting any from the reason you can tell this is not a stratified sample. My brain stopped there for a second. You can tell this isn't a stratified sample because we're not going to get students from every single year. We're only going to get students from the years that are picked. So this is a cluster. We pick the cluster and then sample every single student in those years. So this is cluster sampling. And finally, an administrative assistant is asked to stand in front of the library one Wednesday and to ask the first 100 undergraduates and encounters what they paid for tuition fall semester. Those 100 students are used in the sample. That is going to be convenience sampling. So again, here are the answers. Stratified, systematic, simple, random, cluster, and convenience. And the hardest two, I think, to decide between are systematic and cluster. The way you remember that is remember the systematic, you put them in the strata, and then you do a random sample of the group. The cluster, you put them in the group, and then you select the groups, and everyone in that group is sampled. So those are the key idea differences between those two. All right, with replacement or without replacement. So if you're going to do a true random sample, you could put somebody back in the population. Like if you were thinking of the example of the administrative assistant standing at the library, the person could go into the library, come back out and go in again. And that would be with replacement. He got replaced back into the population. Really, we shouldn't be doing that. But when the populations are large enough, we just assume that it's not going to be having any replacement in because enough people are going to be selected. All right, so let's talk about sampling errors and non-sampling errors. We need to be aware that there are, when you do a sampling process, there are actual problems in the process that can cause sampling errors, and we need to be aware of these. In reality, a sample is never going to be perfect. It's never going to be an exact representation of the population because there's always going to be some influence in it. But as a rule, if you pick a larger sample, the smaller the sampling error is going to be. So let's take a look at what those might be. This is a pretty busy slide. Guess I probably should have broken this out. But let's go through, and these are some of the different types of common problems we need to be aware of. Problems with the sample. We could have a biased sample that doesn't represent the population. We could have a self-selected sample. So these are responses by people who choose to respond. Like if you call all the phone numbers and people are given a chance to respond or not respond, if they choose to respond, they might have stronger feelings about an issue. So that's a self-selected sample issue. Sample size is a big problem. You need to make sure you have a big enough sample size, or you could just pick the one that doesn't work very well. Undue influence. If you ask questions in a way that could influence a response, that's what that means. We're going to go through some examples of these. Non-response or refusal to participate. Obviously, people are refusing to participate. You're going to not have a fair sample of the population. Causality. A relationship between the two variables does not necessarily mean that one causes the other. They may be correlated because of the relationship through a different variable. Self-funded or self-interest surveys. So this is when a person who is doing the survey is looking to support their own claim. Misleading use of the data, improperly displaying the graphs, not giving all the data, not giving context to the data, or confounding factors. When multiple factors on response cannot be separated, it makes it difficult to draw conclusions. So let's go through some examples of what this would look like. So we're going to decide whether the following samples are representative or not. If we're not, we're going to explain. So we're going to do a little bit of pause the video and go on. That's the way online classes go. Regular classes would be more like a discussion. So the first one says to find the average GPA of all students in a university, use all honor students at the university as the sample. Do we feel like this is representative or not? Well, obviously not representative because we're only doing the honor students who obviously have a higher GPA. That's what makes you an honor student. So this is a non-representative sample. Number 2 says, find out the most popular cereal among young people under the age of 10. If you stand outside a large supermarket for 3 hours and speak to every 20th child under the age of 10 who enters the supermarket. Well, this one's certainly better than the first one. However, maybe you're not, if you're at a large supermarket, perhaps that is in a non-representative neighborhood, like maybe it's a very expensive supermarket, and the children going in there are only of the wealthiest children. Maybe they select cereal different than students that maybe from more middle class supermarket. So I would say this is probably not a representative sample. Number 3, to find the average annual income of all adults in the United States, sample U.S. congressmen. Create a cluster sample by considering each state as a stratum. By using simple random sampling, select states to be part of the cluster. Then survey every U.S. congressman in the cluster. All right, well, I don't think that the U.S. congressmen are going to give the typical response for the annual income of all adults in the United States, right? You don't want to sample U.S. congressmen. You want to sample everyone with all different levels of income. So this is also not representative. And finally, to determine the average cost of a 2-day stay in a hospital in Massachusetts, survey 100 hospitals across the state using simple random sampling. This one actually seems like it'd be a pretty good way to do it. I mean, as long as you go across the whole state and you randomly choose 100 hospitals, you're probably going to get a pretty representative sample. All right, that's the end of this section.